SecureNinjaTV is in Colorado Springs at the Rocky Mountain Cyberspace Symposium. I'm standing in Garden of the Gods, world famous for its dramatic fins of sandstone. This place is so outer-worldly it looks like it was created using a generative AI prompt. But this is not AI and it's not an hallucination. Let's talk more about AI right now.
Secure Ninja.
I've just listened to a very interesting presentation by Steve Heibine. He's with HP Enterprise, and you're an expert in AI. Steve, great presentation. How are you doing today?
Well, thank you. Actually, very good. It's been a great week. Got a lot of good information, and hopefully shared some good information.
Yeah, it was a great conference. You gave a very good presentation about AI. Specifically, I was interested in the part about generative AI. That's all in the news at the moment, ChatGPT, etc. And you were explaining, there's a lot of emergent and unexpected capabilities that generative AI has now that we didn't actually foresee at the beginning. You've given a case study about evidence collection and processing. Do you want to tell us about that a little bit, please?
Yeah, it's interesting. Those emergent technologies, now it can understand sentiment, it can understand a lot of intent, it can understand jokes and irony. But one of the things that we did is we said, okay, starting with, you handed a picture, it's multimodal large language models. So this way it'll handle video, audio, text, combinations of that. So what we were able to do is hand it a picture and say, tell me about this picture. And then it would be able to give you more. The easy example was, it was a ship. It was on its side in a river. And what's this picture? It says, oh, it's basically a ship sank. And you say, well, come on, tell me more. And so what it did is it looked at the bow, read the bow of the ship, got the name of it. Then it was able to look up in other information it had and say, this is a ship, it sank in 1951 on such and such river, and so on and so forth. Well, what we've done is we've moved that further to say, okay, since it's multimodal, what if I gave it evidence from a crime scene? Okay, and so we're giving it maybe the officers' notes, the interviews with witnesses, but also giving it videos or pictures and things where it would show what the crime scene looked like. And then what we're able to do is ask the model, what do you see? What is the noteworthy information? It would say, well, this is a trend. I see these, this is a similarity of what's going on here. But then you say, well, what's missing? Or, well, here's the anomalies. This might make sense, but this and this anomalies hang out here. And so what you can go back, the officer or the investigator can then go query it and work in a way that it's interactive to find out more about this. But it's in the early stages of generation. We're working with a police force overseas right now.
Yeah, much like, I've seen studies about how we have these AI judges and they're better at assessing if a person is going to reoffend than an actual human judge. So that sounds similar. Yeah. You also talked about anomalies in that explanation. That's very interesting. I know AI is being used in generative AI for cybersecurity. Tell us a little bit about what you see going on there.
Well, a couple things. First of all, what the adversaries are using it for is basically for phishing schemes. Sometimes you see state actors, they don't speak English well. So what'll happen is some of the phishing they're doing is very poorly written. Even for those that know English, they don't have a great grasp of what's compelling. AI, on the other hand, write me a compelling email that would make them want to click on this link. And what it'll do is they'll write this. And so what they've done is they're using that for phishing activities. Now, that's not going to make someone who's a kiddie scripter all of a sudden get to the point to be an expert. But what it does is, since there's so much of what goes on, is you first get your entry in by phishing, right? Spear phishing. Absolutely. And so you can do some great spear phishing there. Now, on the other hand, what AI can do is, in a defensive posture, what large language models do is they take a large corpus or body of data, bring that in and learn from it. So they call it pre-training. And you bring all this in, and then it learned language, right? I gave it everything from on the internet. It learned about language. It learned about the context. It learned about this thing without us telling it anything. Well, what if we take it on something different, like all this net flow? We got this net flow traffic coming in. We're able to then have it learn what a packet is, learn how packets are divided, learn how what the headers are, what trailers are, what are good packets, what are bad packets, what are adversarial ones. And so that's the type of work that's being done right now with large language models applied to NetFlow and cybersecurity for a defensive measure. We're hoping an emergent capability of being able to predict or catch zero-day would be the goal. But I mean, again, this is early in the studies and early in what's going on.
Absolutely. The other thing I found that was very interesting is you were talking about we're going from preventative maintenance on things like engines and aircraft and ships, and we're going to step that up to predictive and plus. Mm-hmm. Tell us a little bit about more how AI can help us with that.
Yeah. Right now what we're doing is there's a lot of sensors on equipment. Most new equipment will come with sensors built into them. All you have to do is, connect to them. And so you'll know the vibration, the temperature, the workload, the duty cycle, all those types of things, for all the equipment. And if you look at take a ship, a Navy ship is nothing but hydraulics and motors and engines and lifts and things of that sort. Well, to get the sensors and the information off there, what you can do is over time, you understand what they're going to be like, what the vibration might be like, what the temperature might be like before it fails. So what we do is we build a predictive model. So instead of going in and saying, okay, every 3 months I oil this, every 6 months I change this filter, every so on and so forth, what happens is you would be paying for things that for something that wasn't being used as much as something that was overused. So what you want to do is with predictive maintenance, you can say, based on duty cycles, based on the vibration, based on the environmentals, like if it's on a ship, you've got a case where the salinity, the temperature outside, other aspects of it, maybe the pitch, roll, and yaw of the ship may impact the whether or not something fails. So now what you can do is with predictive, you now have the ability to say, I'm going to cut some of my costs out because sometimes the filters are inconvenient. I got to take apart a lot of different things. Mm-hmm. It's like a air filter in a car. I got to take the dashboard out sometimes, on some models. So it'd be the same thing. Why spend that money on a system that isn't ready for it? And why miss on a system that's being overworked to get it before it fails to be able to predict it? So then this way you then control your cost. You're now operating better and it's very cost efficient.
Yeah, and probably less likelihood of failure, honestly, as well as the cost savings. Yeah. And then you mentioned digital twin.
Oh, well, what's interesting is you want to take that to the next step. What you do is you do a digital twin. Right now, they are building out digital twins of Navy vessels. And so with this, they're able to actually have not just the 3D vision, which is the part that we all see, the eye candy. What it is I'm representing what are the temperature of the water in those pipes? What is the pressure? What is the number of people that are on the ship, the actions, directions, all the different information. So what I can do is say, okay, at first I'm monitoring. The next step is go into that predictive nature of saying I can predict some of these things. But you can also go to the next level, which is autonomous. So it'll autonomously repair something. And if you think about how much of our stuff is software-based, I can notice that there's a software issue. I might be able to say, let me adjust for that now. Or other aspects, right? I can control valves and all that. So AI is really good for that once you build out the model.
Yeah, when we were in Prague, we saw a very interesting application where they actually modeled an entire battleship and they were training the firefighters using goggles on how they would get an alert for there's a fire in Section 7. They would actually know how to get to Section 7, so that was very interesting. The last thing I wanted to ask you about is, we see ChatGPT, and even yesterday or today, there was an article on the news about a major hallucination in ChatGPT. Yeah. Tell us about, hallucination, how big a problem is and what can we do to maybe defeat it, defend it, make it less of a problem?
I think about it. We're only about a year or so into, ChatGPT. If you start thinking about it when a hallucination happens, it's because the model really says, you ask me a question, I'll do my best to answer it, even if I don't have the information, right? So what happens is everything we're doing is a probability. So they take what's the highest probable answer and they're going to give it back to you. Well, that highest probable answer could be 3%. pretty sure that's going to be a hallucination. So if you ask it something out of its knowledge range, like for instance, it was trained with information up until 2022, and I ask a 2023 or 4 question, it's going to come up with an answer. It'll tell you who won the Super Bowl, but it didn't have that information. It's just going to say what the highest probability of it happening. So with hallucinations, now how do you stop that? One is you can actually do it in your prompt. You can tell the prompt, don't hallucinate. If you don't know the answer, tell me. Yep. The other thing it does is you can say within every answer, show me the proof of data on that. Show me the document. Show me, where I can get the actual source material. That's another way to do it. There's other things called guardrails. So we put guardrails and use that to be able to do certain things. There's also when people are using prompt engineering to break it, sometimes you say certain things, it'll break it. Well, what you can do is say, okay, you gave me the question. I'm going to use a little bit of AI to rephrase it. So this way, by summarizing your question, I'm now taking out any of the malicious, prompt you might have put in there. And so then I turn it into a prompt that I feel safer. Then it goes to the large language model to do that. So there's a series of things. And remember, we're so early in the journey, it's going to get better and better over time.
Yeah, I suppose if the AI could also give a level of confidence, that would be a good thing.
Yeah.
Excellent. Well, listen, that was a great presentation. Thanks very much for talking to us. Hopefully we'll catch up with you again. Thanks for being on SecureNinjaTV.
Thank you very much.
You.
I appreciate it. Thank you.
Hey guys, thanks so much for watching. Please remember to subscribe and to like, because we have a lot more content coming from Colorado Springs. I'm Andrew Howard from SecureNinjaTV. We'll talk to you again soon.